Welcome to my channel. Today we are going to see one of the most popular language called FBD or function block diagram. Function block diagram is the graphical language out of three graphical language like such as ladder logic diagram, function block diagram and sequential flow chart. Function block diagram is one of the popular language which used to describe the function between the input variable and output variables. Let's see inside. The function block diagram is a graphical language that duplicated the signals and data flow through reusable function blocks. And function block diagram is very useful for expressing the interconnection of control system algorithms and logics. The function and also the function block diagram, the function between the input and output that are connected by blocks by connecting the lines. If we see the example here, each block it is connected by line and each line it is connected to the output of that one, and you can connect many blocks in the same functions. And the function block diagram is described as set of elementary blocks which wired together by a link. So these are set of elementary blocks which connected or wired together by a link to the output. Example advantages of the function block diagram such as it does work well with motion controls, and also the visual method is very easier for many users to troubleshoot the points. And the third biggest advantage of the FBD is that taken many lines of the programming and it can be used with one or several function blocks. So you can use one or many function blocks and it's connected with interconnected blocks, and it will be used as a single output. And disadvantage of this function block diagram that the code can be disorganized using this PLC programming language, because you can place the function blocks anywhere of the sheet. This can be also more difficult during the troubleshooting of that. Let's see the example now. Let's open our previous example for which we developed earlier stage. See here we already have the hardware configuration. So we will go to that function block diagram now. See, if we go in the program below the task mask, in the sections you have to right click the function. Before that you need to see the function. See, this all we created for with function block diagram. See these pumps, example these analog inputs we created for with function block diagram. No? So we will create the new function block now currently. And if you see here you have 240 lines total, and if you see in the right side of the corner you have up to 360. How I can increase or decrease this line? Just go to the tools and go project settings. Project setting, and if you see here in the program downside you have FBD. Click this one and you can see number of row is 240 and number of column is 360. If you need to increase, you can increase the size there. But currently we are going to use the default, and I am going to add now new function block diagram. See in the below the section, right click section and click yes modification. I am going to modify because now I am just selecting the language FBD, and here I am going to add a new name now for FBD underscore test. So once you click OK, see before that you can see the localization and here condition and command. So just I will click OK and it will be see it's automatically created in the FBD test. From here, see it's open the empty page now. From before you are making this FBD, see in the section here, see here you have FFB input assistance, links and everything the same you can find here. See data selection, FFB input assistance, and types of library browser and subroutine, links, toggle pin and jump label, return, comment, and also the inspect windows. This all it will become once you create the FBD. And if you click the FBD here, see here you can even types. If you have some functions, you can, if it will be, you can browse from this place, or if you go to function and function block type, you can find all the what we have here exactly in this project. See here you can find all the application and library set and or counters, timers, scaling, everything you have in this set. And if you go for lib set, you can find complete library set of the Unity Pro language, which it's automatically come along with your Unity Pro application. See, if you type some of the functions, it can be, if you give search, you can find also. And see for or, if you see, instead of I'm searching, I'm going to show you here also. See here and the function C you have R also. See here. So if I click OK, it will be add automatically. And also if you go for help on type, you can find the what is that exact function also in the help on type. And here you can find all the EF, EFB and DFB blocks also. It will become together along with the general library set. And in the application what you added, everything it will be appear in this type, DFB type. And EF type, it will be automatically by the Unity Pro application. If we click the help on type, see here you can find the particular type. See here, and this AND function, what is the how it is working, you can find from this description of the any of the blocks. And it will be shown in all the languages: ladder, ST, instruction list and FBD. See here. Now what we will do now, I will going to add the new function here. See here FFP type, I just put or, see it come automatically the same function. See here, and if I click OK, you can add here, and you added, see this one for or. Similarly, if I go for another one called AND, I will also add, see the FFP, I will type AND function. See if I click AND, it will become also AND function as well. And you can see the difference. See here, and or, it will be the same, but or means it is adding like a plus. Like if it's two condition, input 1 and input 2, it's on, then any one of the condition is on, it will be on also. See now I drag that or function completely. You can drag and drop how much inputs you need, you can drag by yourself. See, you can adjust the IOs. How many you need. See in the ladder logic you have to make one by one, but here you just adjust, drag the line, you can find complete inputs you can add directly. Even you can add the show enable or enable output. See here, it will be add automatically. So this is the main advantage of the function block diagram, because you can drag and you can adjust your input outputs within few seconds. Okay, so this block, it will be used for any bits to like any of the input to any of the output, like one output. You have example 16 or 17 inputs, it will be give one output. Here any one of the input is on, in the OR it will be on, but in the AND function, so it should be on all the functions, you know already, for the AND function. If I type now some example, some different things, like example bit to word. See, if I don't know how to make, just check here. See, actually I need to add bit underscore to underscore word. So it's not appearing. See here, I will show you to you. See in the library set, you can browse down like a bit. See add. See, this is double word to real, and if you go further upside, you can find double integer as word also, and double integer to bool, And if you go still further up, yeah, here, yeah, yes. See here, you can find boolean to integer or byte or double word or anything. See now bit to word. Just I will click bit to word. See bit underscore to underscore word. If I select, see it will come automatically 16 bit and one word. So all the functions you can drag and you can adjust the size based on your requirement. So this is the beauty of the function block diagram. And you can put in you can place in anywhere of the section. Okay, it will be automatically adjust. And it will be run from left first and it will be run on the serial number. It's mentioned 1, 2, 3. So based on that number it will be run the logic. See now I will add the command. I will just show for demonstration purpose here. And I will click and I will add the function here. And function. See just you can adjust the command based on your requirement. And already I told you can be add or if any one of the input is on, the output will be on also. See I will write for your explanation. If any one of the input is on, this one you can learn from the basic digital electronics as well. See here, if any one of the digital input is on, then the output become on or the output become true. Okay, here if for output for AND output for AND the output it should be on or it should be satisfy complete condition input 1 up to input 6. It should be on all the condition. If all the inputs are on, then only the output become true or the output become on. This is the difference between OR and logic. And for bit to word, you know already. If this bit, if any one of the bit is on, it will be give as per the word. Example, if you first bit is on, it will give you 1. If second bit is on, it will give you 3 because 1 plus 2 it's equal to 3. The output will be 3 like this. So and also the connection. See if they make the interconnection, you can make directly. See here I can connect with 1 and I can connect to the interconnection with the other one. So it is very easy to make a interconnection between all the points. But if you make the interconnection between output to input, there is some error because the output of the bit to word is word, not the bit. So you cannot connect to the input of that same word. But from the input bit, you can connect to the each bit because it's all boolean. See here, if I connect like this, you will get the error because you are getting the again the it will be not work because the output is invalid source. So you need to be understand if it is blue color means there is some error. And when you are connecting, see now I am adding one more OR and I am connecting the output of the AND. I am connecting to the OR bit. See it's connected directly. And this output I can connect to the input to the bit of the bit to word function. See directly. So this is the basic logic. See here, if I give instead of connecting directly, I will give one example, one word like one bit. I can use the same bit here out 5. It will be connect. Instead of link, I will use the one of the temporary variables. See, this is similar to that link only. So this is the basic of function block diagram. Okay, now I will remove all these things. I am going to make one of the pump logic now. See now I am going to make one pump control. So I will write pump control. See, for this pump control, first I will add function, and this function I will add 5 input example. See here I am just going to browse the existing IO which we used in the earlier class. See here I am going to use pump, not pump mode, pump. I need pump auto, no? So I will search for pump auto. See here I have many IOs. See here you can find the IOs. If you click the address format, you can find the IOs. See here pump run, pump trip, moisture temperature, pump auto. I added the pump auto now, and the second input I am going to add. See here, double click that one and browse, and I am going to add for the second input pump underscore SCADA underscore auto. When the pump is in auto and it is in SCADA auto, and I will add the logic. This is for automatic logic for the pump control, and I am going to take pump start interlock, and this should be now stop interlock. So just I will browse and I will give pump 1 underscore stop interlock, and it I give a negative pin for that. And the next one I am going to add, see here pump 1, not pump 2. See pump 1, can you, I will go upside little bit. Pump 1 healthy. See, sorry, pump 1 duty. So I will add here the condition. The pump should be auto, pumps could be in SCADA auto, and stop interlock, no stop interlock, and it should be duty. Now I am going to add this second AND block. From here I will just make going to make 4 input. So I am adjusting the inputs. See here, just I am copying the first one, pump 1 underscore auto underscore indication, pump 1 auto indication. And for the second input, see I can browse here directly if I have, but if I am not found from here, so I need to be add directly either in the variable list, or I can make directly from here. I will show now. See, just I am trying to search pump 1. See, I did not able to find set auto manual. So I'm see here we have only SCADA auto, pump 1 SCADA auto. So what I will do now, I am going to add directly here pump 1 P1 underscore set auto manual. So I am going to add direct one function block. See, it will be as create variable, yes. After that I am going to add one more function here. Just I am going to browse from the variable list called pump 1 SCADA manual command, and I am going to add this one pump 1. See, I will put negative pin for this, and I will copy the same. Instead of manual command, I will put manual stop command now. Pump 1 SCADA. See here, if I come down little bit, you can find here pump 1 SCADA manual stop. So I added one is for the automatic command, one for manual command. So if this two, it is used for start interlock, start command. Now I need to make for stop also. See, I will copy before doing for the stop. See, I will copy paste this and block, and I will change this one to negative. Instead of negative, I will put positive for the set manual, because in case if it is set and there is no manual, it will be stop. This is for stop interlock. And now I will add here one OR block, or boolean, means you can add either OR directly, or I will put boolean or boolean. See here, I will make the link for the first input, and this is for second input. Once I make the link, this means the first automatic and manual, it's going to here OR block. If any one of the automatic or manual is on, this means the output will be energized, and it will be add directly to the another, it will go to another link. We connected the OR block to the AND block for the first pump on command, and for this OR block I will copy paste one OR block again. This is for stop command. So I will make one more block here. See, already we have AND, so I will copy paste one more and here I will change this one to P1 underscore auto command. For here I will put, this is for see, I will just browse for, instead of SCADA manual, I will put healthy. If there is no healthy, the pump is in auto and it is set auto from the PLC, and there is no healthy, and it will be stop the pump. So this is the condition for this block, and I will add one more block here down, called timer on. See, this one I will put directly with the timer on this output. See, here I will give timer T slash 1 second. I will connect the timer to the from the link, and I will give the output to the OR input true. And this one for the another one I will connect direct to the input 1. So we added the one OR block, and that's already connected, and I am going to add more also. So what I will do, I will make a little bit more, move to the right, so it can be visible properly. And I will also add all the feedback, fault feedbacks, everything. See, here I will add pump fault feedback, and also I can add if you go further down, there is no pump. See, here I will put this one as a negative pin, so no auto, and also I can find some other signals. Before that, I will add one more block here. I will put one timer. This timer we can add a run. In case the pump is started, you given the pump command, but the pump is running, but you did not get the feedback in 30 seconds. So you need to be give output for this one also. This is for pump feedback run, and you are going to give here, see here, set reset. I will add set reset function here. See here, I will link the output to the set. And for the reset, see, I will add directly the function here through the pump 1 fault reset directly. No? So the pump is, if it is not run in 30 seconds, like that is, it will be give reset. Or you can press the reset button from the SCADA or any push button, it will reset the pump. And for the other signals, I can add directly from the variable list. We have some other signals before moisture alarm, and also we have temperature alarm, and also that, see this one, pump under pump 1 underscore temperature alarm, and also I can add pump 1 moisture alarm. See here, yes. And if we have any other alarm, say healthy, it should, if it is if there is no healthy, also it will activate the signal. So based on your requirement, you can adjust this one. So once you make this condition, then I can add this OR function to the command directly. See here, just I'll put this one as negative pin, and I can add this output or Boolean output to this negative pin. See here, now I will give the pump command directly. So if the conditions are satisfied, it will run the pump directly, and if the below conditions are not satisfied, the pump will be shut down automatically. See here, this one, pump start commands. So this is the basic creation of the pump logics with function block diagram. So if you understand this logic, so you can make by yourself to create your own logic directly by using function block diagram. So this is very useful. See here, you can connect all the IOs by directly with this AND and OR block itself, and you complete the complete logic. But if you make in the ladder logic, it will be make lot of rungs and everything. But here you have simply one block, it will be have many functions, like many pins. So you can connect many IOs and it will be take in one block, and you can connect all the functions and connect it directly to the start command. So this copy, if you make this one same function in your derived function block, it can be used, you can call this same function in many of the IOs. I will show you now. See, just I will copy, I will save, and I will compile. See, there is no error currently. Just I will recompile, rebuild the application. See here, you cannot find any error because this means everything is okay. Okay, all the logic. So this is the basic step how you are going to create the pump control in the function block diagram. Similarly, if you copy paste the same function in the derived function block, see here, I will show you here the pump logic down. This is duty pump. See here, if I open the pump logic, this is the similar same function. See here, pump command. See here, if you this all it is in, see here, we already added some of the block called mode, status, daily run, everything. See, I will show you here. Just browse here, right click, add FFB, and type this same name, pump, or you can browse also. See the pump, just I added the same block here. I will show you now. See this same block, you make the complete logic. Now it is inside the block, so this block you can be used in any of the place also, because if you make the same logic in the derived function block, this means This derived function block can be called in many of the places, which I explained in the function. In the Siemens also you have in function and function block, no? Similar to that, same here. So if you see here, all the complete blocks, it is there inside the pump. And you see here the status, healthy, mode, here these all the outputs. You can, if you double click the pump logic, see here, you can find here, see, it is the status, mode, status, and also if you upside reset run hour, daily run hour, and everything. So the input and outputs are created directly by using these blocks also. So there is two way you can create the function block diagram, either directly in the function block diagram, or you can make through the derived function types. And you can call this block in every wherever it is required. If you have more than, example, you have 100 valves or 50 valves or 50 pumps, at the time it will be very useful to create through the derived function block type. Otherwise you can use directly by how we make the function block diagram now. You can use similar to that. So I am saving this function. See, there is no error. Okay. So just I will rebuild the application. See, it's built and there is nothing error came. But this one I did not configure any IOs. No? So I will remove this one, because here I configured all the IOs, but in the pump I did not configure. I hope you enjoy this video. If you like this video, kindly press the like button, and if you need any topics, kindly comment, and also if you kindly share to your friends and network. Thank you for watching this video. Thank you.